Alrighty, folks. So we're gonna kick this off. Give me a second, just take a swig of coffee real quick. All right. So it's good to have you all here today. My name is Phil Zito, the founder and CEO of Building Automation Monthly, where we help companies to assess their capabilities of their existing employees and help them train up those employees so that they can execute building automation work. In today's webinar, we're going to be going through a lot of stuff. If you just joined, this is going to be a different webinar than what you've probably experienced in the past with PowerPoint slides and folks talking awkwardly, looking at the camera. We are actually going to be talking through what a building automation system is, how it's structured, the parts and pieces. Then we're going to be looking at a building automation system, which you should be seeing on my screen right now. As we move through this, please post any questions into the questions box, and I will answer them based on what the question is, either during the discussion or at the end. All right, so let's start off. So I'm going to assume you all know nothing about building automation systems, and we're going to work from there. So the first couple minutes may seem very basic, but I promise you we'll get pretty deep pretty fast, so stick with me here. All right, so let's take a look at a building automation system architecture. And building automation system, what it is essentially is a way of controlling control systems. So you've probably heard of pneumatic systems, you've probably heard of electromechanical systems, and you've probably heard of direct digital controls. Well, most of our controllers that we see, like this Honeywell Spider controller right here, this Johnson DX9100, this Trends controller right here, these controllers are control systems. They're direct digital controllers. So what they do is they take a analog output, right? So you take an analog output or an analog input, and you're taking some sort of digital logic that's inside the controller, some ones and zeros, and converting it to analog signals. That was the big deal about DDC, right? It was able to do that. So building automation overlays these control systems, as we can see in this architecture, and this will all make a lot more sense as we move through this webinar. But it overlays this control system so that you can interact with the control system. Because in the past, the only way you could interact with pneumatics or electromechanical systems was either by adjusting dials or going and looking at gauges, adjusting accumulators, things like that, adjusting your pressure settings. Nowadays, with building automation systems, we're able to visualize and interact with control systems. So let me clear this off and let's talk through. So let's say you needed to go and look up a building automation system because for whatever reason you were asked to provide a new building automation system or you were asked to engineer a new building automation system. Well, the first thing you'd need to understand is kind of where you are interacting with that building automation system. Let's see if we can get a good graphic on here. I like to use real graphics. And if you guys are ever looking to go and actually look at building automation systems, I recommend just looking at the architectures in Google Images. And so looking at this one right here, right, this enterprise architecture powered by Niagara, and we're just going to talk about Niagara in this because it's got such large market share and familiarity. We don't recommend any given building automation system. It's just that this one is the most popular in most cases. So a building automation system consists of a 4-tier architecture, okay? And let me open up a new notepad so we can draw here. Consists of a 4-tier architecture. And that 4-tier architecture consists of a server at the top, okay? And this server then connects to supervisory devices, okay? Y'all with me so far? I know this is pretty basic for some of you. Stick with me. When we start digging into Niagara Workbench and looking at the live system, if you don't have this down, then it won't make sense to you. All right, so the supervisory system has field trunks or field buses, okay? And those connect to field controllers, which we'll just label FC, which have inputs and have outputs. So as we're looking for a control system or a building automation system, and our customer or we being the customer are looking into this, we have to decide what we're trying to work with. Are we trying to work with field controllers? Are we trying to work with pulling in existing field controllers, in which case we're using a supervisory device? Or are we pulling in an existing system, in which case we're using a server? You all with me so far? Give me some feedback. This is making sense, hopefully, because if this isn't making sense, then we're going to have to step back even more basic. But I feel that you all are getting this. So the 4-tier architecture, right? A server, supervisory device, field controllers, which are connected via field trunks to the supervisory devices, and the field controllers consume inputs and outputs. And like I said, we'll look at this when we move into the Niagara Workbench. So let me erase that drawing, move back here. So what I like to do when I'm teaching this to folks is I like to show kind of what it would be like dealing with field controllers, dealing with supervisory devices and servers. So we just got from Honeywell, they just sent us a Cipher 30. Unfortunately, I didn't have time to get it installed prior to this webinar. We just got it, I think, last week, and I didn't want to rush through that. But if you were looking at an IP controls solution, this is an IP controller. And we talked about IP controls in our previous webinar. If you're looking for that info, go to our website and it's up there, or it's on our YouTube channel. You can refer to that. It's a really good webinar. So with IP controls, oftentimes when you are looking at any control solution, this is not just for controllers, this will work for supervisory devices, this will work for architectures, you're going to find yourself getting 3 kind of different documents. The first often is called a sell sheet, and this just gives a very high level 30,000 foot view of what the system can do. From there, you'll get a product brochure, which will kind of go through, hey, the product line, this is what it is. Then you'll get a product data sheet, which will give you a lot of data and information related to the product, and then an implementation sheet. This is normally how manufacturers will structure their documents. The reason this is important for you to know this is that as you're working with building automation systems, depending on what you're trying to do, you may use all of these documents or you may use none of these documents or one of these documents. So as an owner, you may just be purely concerned with a sell sheet and a product brochure and understanding how this fits. As a specifying engineer, you may be concerned with the product data sheet. As an implementer, you may be concerned with the engineering user guide or installation guide. It may be called different things. Knowing that you can get this information is going to make understanding building automation so much easier, because at the end of the day, if we go back to this original architecture drawing right here, all a building automation system is an overlay that allows us to interact with field controllers and to either program those field controllers or pull data or send data to those field controllers so that it can be visualized within a user interface. Okay, that makes sense? That's all building automation system is. I am not going to spend any more time describing that because now we're going to shift directly to the software. And this is where we are going to spend the remaining 50 minutes of this webinar is in this software. So what you'll notice here is I've got some configuration software called Niagara Workbench. Depending on what manufacturer you're with, you may have different software, but usually it remains the same. What it is that you have a software solution that allows you to create a building automation database. And once you've created that building automation database, you're then able to add devices to it. You're able to map in controllers. You're able to map in inputs and outputs. And so that's what we're going to talk about here is I have what's called a JACE 8000, which is a supervisory device. And it is allowing me to pull in field controllers, which we'll see. We're actually going to discover a field controller as part of this webinar. We're going to add points. We're going to talk about points. We're going to talk about extensions, trends, graphics, all of that. We're going to go through all of that. That's why I said we're going to dive really deep. And your challenge is to ask me clarifying questions as you see things that don't make sense to you, so that we can learn building automation together as we move through actually adding these devices. So I see we got one question: is this software valid for all Niagara-based devices? So this is Vikon Workbench. The type of workbench you use is dependent on the manufacturer. So, all right, so we've got a station, and I've added this JACE 8000 to my software here. Now I need to go about adding some controllers. So remember, I said I have a supervisory device, and my supervisory device uses a field trunk in order to go and pull in controllers, and these controllers are consuming inputs and outputs from devices like thermostats and actuators and pressure sensors, etc. So in Niagara, what you have to do is you have to add a driver to allow it to consume a network. In our case, we've added a BACnet driver because BACnet is one of two protocols that you will primarily use in building automation, and those are BACnet and LAN. We're not going to dive very deep into BACnet and LAN. We may do a BACnet webinar in the future, but BACnet is one of the protocols. And what we're doing here is I'm consuming some BACnet IP controllers. I've got them connected to a network, and I'm going to discover them. So I add my driver, and I go and I discover my BACnet controllers. And my BACnet controllers, you can see I've already discovered them. They're added to the database. And when I go and double click on them, I can actually add them to the network. Okay, and when I add them to the network, so now I have a supervisory device, right? I have a supervisory device. I have a network, a field bus. And whether this is MSTP or IP doesn't really matter. I'm just showing you that we are connecting to a field controller and pulling it in. Once I've connected to that field controller, I am then able, I'm then able to go and discover points related to the field controller. So within, and this is a good time to talk about objects and points and those kind of concepts. Within building automation, you'll hear two concepts used interchangeably, even though they should not be used interchangeably, and it freaking confuses the heck out of people. And it's this concept of objects versus points. So points, quite simply, are points that, let me show you. Let me show you how this would look. Let's go here to the wire sheet, okay? So these right here are objects. I have a folder, right? I have an alarms folder. I have a schedule object. I have a history object. I have a bunch of different objects, okay? These are objects. They are not points. Now, there's a reason why I'm using the difference here, because if you're trying to communicate to your building automation contractor, or you're a building automation contractor and you're trying to communicate to an engineer, using the right terminology is going to help you immensely. When it comes to points, with most building automation systems, we're dealing with kind of 3 points. And those are a Boolean point, which are a true-false point. We're dealing with a numeric point, which is a numeric value. And we're dealing with an enumerated point, which is a state-based value. We're going to come back to these, and we're going to go very deep on these. So if this makes no sense to you right now, that's totally fine, because we're going to come back to this when we start looking at how do you program in a building automation system, okay? So like I said, we have this controller, and we map in points. Now we can map in what are called logical points and physical points. Logical points exist in the software. That's kind of the benefit of DDC controllers, is that because they have essentially a computer built into them, you're able to have software points, whereas with pneumatics and electromechanical systems, you only had the physical devices themselves. You couldn't add abstract things like set points or resets. Those are things we can now bring into our building automation system in the form of logical points. But we also have physical points. And with physical points, we can see, for example, I have an outdoor air temp. And this is a BACnet logical point that is representing a physical point in the field controller. Now, I know that probably confused a couple of you, a logical point that is representing a physical point in the controller. But that's how a lot of these building automation systems work, is you have these supervisory devices and you have these field trunks that connect to field controllers. And then inside the field controllers, you have physical points, like in this case, outdoor air temp. But in order to share it to the supervisory device, or in order to share it to some other field controller, you need to make it a logical point. Think about this. You have a USB drive and it has a Word document on it. That USB drive is a physical device, but within it is software, right? That Word document. In order to share that Word document throughout the network to other computers, to other USB drives, that has to be software. And so that's what our field controllers are doing. They're taking logical or physical points, in the case of outdoor air dampers, outdoor air temps, return air temps, etc., and they're converting them to software that can then be brought up into our supervisory device and represented as graphics. Making sense so far? Have I lost any of you? Do I need to back up? Do I need to go deeper into any topics? Or are you all good? It's totally fine if I need to slow down or if I need to explain something a little further. I want to make sure that you all are following because this is for you. Okay, all right. Seeing good feedback from folks, we're going to continue along. All right, so we've went and we've brought in our physical controller. We've got our points. And now we have to do some programming. Now, with most controllers, you are not going to be able to program through the same software that you go and set up the database on. And this is what frustrates the heck out of some people, is that they go and they set up the server, they set up the supervisory device, they map in the field controllers, they pull in the points, and then they realize they need to change something, but they can't change something because they don't have the controller software. Now, manufacturers are working to making a single tool that will allow you to configure everything, but not everyone has adopted that methodology or approach. You will see that though starting to roll out as the years continue because that's kind of where the industry's headed. The reality though is with most of our field controllers, we have to actually open up our field controller software. So let me do that. Give me a couple seconds here and I'm going to go and I'm going to open up our field controller software. So let me go to that and open up the software. And there we go. So I'm going to open up this software right here, and this will allow us to connect to a controller. Let's figure out the IP address on this controller because I'm using BACnet IP controllers here. What are we dealing with? 192.168.0.9. Okay, so let's open that up and let's go here and let's open and see if we can't open this up. This may not work. No promises, but we'll see. And while that does its thing, we'll wait, waiting somewhat patiently. All right, let's take a look. Right there. Oh, that's why I grabbed the wrong IP address. Like I said, we don't script any of this. We just go through and do this. There we go. That'll be better. Usually helps if you have the right IP address. All right, so now we are in the field controller software. So we saw that here we're configuring our supervisory device, we're mapping in our controller, we're discovering our points, but here we've actually got the field controller software itself. And so if we go in here, we can see that we have some logic in here, right? We can see that we have logical points. Let me go over here, show you. We can see that these logical points are coming in and we are actually sharing them as BACnet objects. So this is all logic in here. And we can just look through here and see kind of what we have built into this. And so if I were to go and add more BACnet points, which we could do, and then we would be able to go and discover these BACnet points as well via the software. So we can kind of see all of this. So if I go here to my BACnet client, there we go. Here are the BACnet points that I'm sharing, right? And we can kind of see that these BACnet points are actually tied to physical points. So they are connected to physical points. So if I were to go and command these BACnet points via Niagara over here, they would actually affect the physical points. Now I know we're kind of just blazing by this at the 30,000 foot view, but this is what you do within the world of building automation. So when you hear about someone going and installing a job and setting it up, is they're setting up the supervisory device, they're mapping in the field controllers, they're discovering the points, but they're also going into the programming software and they're writing programs. You know, they're going to their control stencil and they're adding logic blocks. And those blocks then come together to form programs that allow you to execute the sequence of operations. So far we've talked through going and having our configuration software for the supervisory device, adding a supervisory device, adding a network, discovering field controllers, discovering the points from those field controllers, and the configuration of those field controllers using a external software. So in our case, we're talking about this CPT software for EasyIO, and we're configuring the field controllers using our programming software, and then we would download, well, actually, I think this is live programming. So that's actually another good point, is live programming versus compiled programming. So Niagara is live programming, EasyIO is live programming. And what that means is that as I make changes here in the field controller, they instantly reflect. Compiled programming is where I have to compile and download the program to the field controller, which you'll see in some legacy building automation systems and still some modern building automation systems to this day. All right, so at this point, we've created our field controller, we've added our program to it, we've modified our program, we've mapped in our points, okay, so we've got some points here, and now we have to start building out the graphics, we have to start building out our extensions, we have to start building out our schedules, and all of this before we can ever set up users or anything like that. So at this point, you should have an understanding of what the four parts of a building automation system are. Those are the servers, the supervisory device, the trunks and field controllers, and the inputs and outputs. You should understand that we utilize software to configure supervisory devices and databases. And we utilize that same software to map in our field controllers and discover our points. We often have to use a second set of software known as programming software to actually go and program the field controllers. And it's at this point that a controls engineer or controls technician would discover these points and would start to say, okay, the spec says I need to trend X points for X amount of time, or I need to have alarms on them, or I need to have schedules, and they would start to set that up. So let's talk through that though. Let's talk through, let's take a look at a sample program here. This is a simple program that is driving a cooling only VAV box. Pretty straightforward program. I've got an occupancy schedule going into a PID loop, and that PID loop is taking an occupied or unoccupied set point and is driving a damper output based on it. This is a program. When I'm working with this program, these are the points that I would map in, both the logical and physical points. Once I've done that though, I have to go and create extensions in order to be able to monitor those points. Now, we haven't created graphics yet. We haven't set up users. So, oh, that's awesome. I got a, one of the comments says, I have so many people distracting me. Please tell me this will be available. Yes, we do post our webinar recordings on YouTube. And you should get an email with the webinar recording. Now, the benefit of being here live is that at any time I will answer any of your questions. And at the end of this webinar session, I will answer any questions you have. So feel free to ask. I'm here to serve you. All right, so as I mentioned, we have this program here. We have our physical points and we have our logical points. Now, once we have these physical points, we may come across something that says trend the zone temp every 15 minutes. And this is where we start to have extensions. So we have our objects, like the folder object right here that my cursor is on. We have our physical and logical points, and we're going to have extensions, which are also objects. Now, extensions tend to come in 3 different types. You could argue 2 types if you wanted to be technical and say that you have trend or histories, depending on what manufacturer you're dealing with. And those are historical loggings of data points. So if you wanted to troubleshoot why a zone or a space was cold, you could look at the histories to see where was the damper position, where was the zone temp, and where was the discharge air temp at this point in time. And that's the benefit of histories and trends. And we'll talk through why the 15-minute interval is used and how that came about and the difference between interval and COV in just a second. If you want to be alerted when a system or a point or an object goes out of where it's supposed to be, it's not where it's supposed to be, it's not controlling, that's where alarms would come in. Some folks call them events, most folks call them alarms. And alarms will be able to tell you, hey, I've got an issue. And then finally, you have schedules, and schedules allow you to tell stuff when to turn on and off. So pretty straightforward. Let's add some extensions though. Let's say we wanted to monitor this zone temp. What we would do is, in the case of this software, we would go to history and we would go to extensions and we would say, okay, zone temp is a point. It's a numeric point, so I know that I have to use a numeric history or a numeric trend. And now I have 2 choices. I can do an interval or a COV. In the past, we would only do intervals. We would do 15-minute intervals, and the reason why is if you think about a space, your average air changes in a space are 4 air changes an hour. So 4 divided into 60 is 15, right? So that's where that 15-minute interval came from, is, hey, we're going to do that. Also, some folks will argue that the 15-minute interval came because of calculated capacity of trend storage, but most of the time it was based on the space changes or the airflow change rates. All right, but nowadays, these supervisory devices have tons of capacity. We are not limited. Anyone who tells you that a BACnet or a building automation network is limited these days doesn't know what they're talking about. Legacy systems completely agree. The networks are limited by the device's abilities by the field controller's abilities to send data to the supervisory device. Nowadays, though, our field controllers are almost as powerful as our supervisory devices, and BACnet MSTP has more than enough capacity when at the correct baud rate to send data, and IP definitely has capacity. So nowadays, we see a lot of folks switching to change of value. Now, change of value is nice because it does exactly what you think it would do. So first, let's look at interval, and then we'll look at change of value. So I'm going to add a numeric interval right here. Okay, and what's going to happen is it's going to show up under my point as an extension. And under this, I can set, my interval period. I can set where I want it to go, what I want it to be named. I can set what happens when my repository where I'm storing my histories or trends, what happens when those get full. Does it roll to a database? Does it roll over, et cetera, et cetera. Also, so let's delete this real quick. There we go. And let's add change of value. So now we're going to add change of value. Change of value allows us to go and record a history event when the value changes, and changes by a specific threshold. So the nice thing about this is that it is no longer tightly coupled to the interval. It is now independent of the interval. If it's constantly changing, then we're able to record that. The downside of change of value is when you had everything at 15-minute intervals, it made really pretty trend charts. You could see stuff. Downside of COV is that you may see spikes depending on when things are changing. In my opinion, COV set up right provides a better troubleshooting tool than interval, but you just need to be cognizant of what you're doing. And we're not really going to dive into setting up COV because we'd be here for a while and we only have 30 minutes left in the webinar. And we haven't gotten to graphics, users, or front ends or anything. So just a quick touch base. Are you all still following? This still making sense? I know, like I said, this is different than probably any webinar you've been through in the past. So let's delete this. Let's go and delete this and let's talk through our actual alarm extensions. Okay, so now we're going to look at alarm extensions. We're going to go here and I'm going to go to alarms. Alarms, much like trends and histories, are of different types. So in our case with zone temp, we're just going to use a simple out of range alarm. And we'll take a look at this. And what would happen with the out of range alarm is you would have a fault and you would have a off normal, okay? Now, off normal right there and fault, this tends to throw some folks. What I like to say is that off normal is where I have my alarm and fault is where I have my sensor issues. So if I have an issue with sensors, that's how I like to do it. That's not how everyone likes to do it, but that's what works for me. And so you would say, all right, well, if I know my sensor range is 312 degrees and like negative 50 degrees, then I'd put that and I could say sensor out of range. You could also set that up on the point, by the way. You don't necessarily have to do that in an alarm. So I got a question, do I recommend setting standards on what type of history to use with types of data, temps, dampers? Absolutely. That is something I feel that a lot of owners are setting themselves up for failure because they're not defining that. 3 things you should be absolutely doing right now as a building owner or operator. And if you are a contractor or a consultant, you should be recommending this to your building owners and operators. And trust me, I know from experience they will pay you to help them do this because they've paid us to help them do this. And that is 1, creating a naming and metadata standard. So creating naming and metadata. So naming is, ZN_T. But metadata is tagging. So you've heard of Haystack, which is my preferred tagging dictionary. And Haystack basically allows you to have data about data. That's what metadata is. So zone temp would be qualified as a sensor. I don't know if we have the Haystack library set up on this. We may actually. Let me take a look. If I can type, hold on here. There we go. So what you would do is on a Haystack tag, you would add that tag dictionary. Do I have that set up in here? Yes, I do. Awesome. Okay, great. So since I have it set up, I can actually show you this. So you would go in here, you would click Edit Tags, and we would go under Haystack, and we would go under, I think it's Zone. I think it's Zone. Don't quote me on this. Pretty sure it's Zone. And see under Zone, see how I could say Zone Air Temp? Well, I can go and add that right here. I can add zone air temp as a tag. And then when I search or I use analytics, all of that is defined. So step 1, I would make sure I have a naming and tagging or metadata standard for my buildings. Step 2, I would make sure I have an alarming and trending standard for my buildings. Step 3 is I would make sure I have a graphics standard for my buildings. Those 3 things, now you may be like, but Phil, what about a sequencing standard? What about a scheduling standard? Yeah, those be great. I absolutely agree. Those would be awesome to have. However, if I could only do 3 things, I would do those 3 things because they directly impact the operator. And the operator is the person who's going to be touching this the most. Sequencing, Yeah, it's great to have sequence standards, but oftentimes the folks who operate the building are not involved in the construction process. So their ability to validate the sequences are actually properly implemented is hit or miss. So I would focus on those three things which directly impact the operator. All right, so going back to alarm extensions, so you set these up. When the point goes out of the alarm range, it generates an alarm that shows up on the user interface. All right, so we've talked about alarms. We've talked about trend extensions. Now we're going to talk about schedules, and then we're going to talk about graphics and users. Okay, so schedules, pretty straightforward. You will go and add a schedule, and you can have multiple different types of schedules. And so under this sample program, I'm just going to add a Boolean schedule here. And then we'll go here and we'll grab our Boolean schedule. And a schedule is just going to let you say what time you want something to go on. Now, my personal philosophy on schedules is that you should schedule equipment individually based on occupant patterns. So if you have 3 air handlers that serve customer A and customer A works certain hours, then those air handlers would be tied to customer A. And if you have customer B, then those air handlers that serve customer B would be tied to customer B, and then your atrium and things like that would be tied to a common schedule. Having that in place is one of the easiest ways to save energy within a building, just implementing a true occupancy-based schedule. And there's integrations you can do to tie to Outlook and look at calendars and all sorts of stuff, but that's way beyond what most folks need to do. I'm going to take a sip of coffee 1 second. Give me a second here. Okay, so from these schedules, you will get an output. And then that output, right? See the Boolean schedule? That output can go to my occupancy point. I always like to have an occupancy point, even if I have a schedule. That way I can override the occupancy point and not have to mess with the schedule. That's just my quirkiness. All right, so you've got the schedule mapped in. You've got your alarms and trends set up. You've got your points mapped in. You've got your controllers mapped in. You've got your supervisory device. Now it's time to go and start building out our graphics. Now, in the case of graphics, what often happens is you will have kind of 3 types of graphics. So one type of graphic you will have is the home graphic. This home graphic will allow you to go and have kind of an overview of your building, an overview of your systems, and the home graphic will tend to link to system graphics. And system graphics, right here, will tell you kind of what's going on with a system. And then from there, the third type of graphic, which we don't have on here just yet, is a floor plan graphic. So the typical navigation for graphics will be a user logs in and they're able to access graphics based on their user profile. And based on that profile, they're going to see an overview graphic. And then from that overview graphic, they are going to be able to go to a floor plan graphic. And from that floor plan graphic, they'll be able to go to any systems on the floor plan. So graphics pretty straightforward, and you can view them typically in either the software like this or via an HTML5 web page, which we're not going to show in this just due to time, but that's how most folks are doing it nowadays, is they're using HTML, which is basically your web browser, right? Just your simple web browser. Any questions so far? Still pretty straightforward. So with graphics, you go and you add the points, you link the points to the graphic. You can use template graphics. That way you can repeat over and over again what you're doing. And then from there, you set up users. So far we have our building automation system, we have our supervisory device, we have our trends, alarms, graphics, programs, points, controllers, our field trunks, and now we got to set up our users. Within users, right, we set up a couple different user types, and the user types, based on their roles, will be able to do certain things, and the objects and points will have categories associated with them that are based on these roles. So certain roles will be able to interact with certain points and objects. And this is something that's really important to specify. This is something I see a lot of owners and operators get wrong, is they don't have this level of granularity, and then the maintenance guy goes in and accidentally deletes the discharge air pressure set points and shuts down air handlers or wipes out balancing values. I've seen it happen time and time again. And so it's important that we regulate what folks are able to control by going and setting up users and categories and roles. Now, this will look different based on whatever manufacturer's software you're using, but these terms are pretty synonymous across the board. You have user types or roles, and those roles are associated with categories that allow you to get very granular. You can see, right, I can pick what points they can actually see, control, and interface with. Once all this is set up, then you have a functioning building automation system. And that is how building automation systems work. That's how they're structured, that's how they're implemented, and these are kind of the steps and processes that someone would take, granted very abbreviated, when they're implementing a building automation system in the field. So at this point, we have plenty of time for questions, and that's kind of where I wanted us to be. We didn't have enough time for questions, I feel, in our previous webinar, so I wanted us to have even more. So at this point, feel free to type in any questions you have, and I will take you through the answers. Anything that was unclear, anything you may have heard that you'd like clarified, if you want my thoughts on any particular topic related to building automation, this is your time. And I will just wait for you all to ask questions because we've answered questions throughout this. Let me ask you all a question though. Did this make sense? Was this clear? Okay, good. Did you all learn something? Awesome. What else would you like me to cover? Okay. How do these graphics end up in an HMI, also known as a front end? So that's another thing, right? We've got students in Europe. We've got students in Asia. We've got students in America, obviously. And everyone seems to have different terminology. And that is one of the challenges of building automation, is the terminology. You have some folks like myself who will call it the front end, or the GUI, the graphical user interface. Other folks will call it the HMI, the human machine interface. So basically what happens with that is you see these graphics right here. Now, Niagara N4, I really want to try to stay vendor agnostic, but I'm going to describe the capabilities of the software just to illustrate a point. They allow the capability for graphics to be displayed on HTML. So what we would do is we'd actually go here under the user service. And like I said, I greatly abbreviated this presentation, but we would actually go in here and set up their default web profile as an HTML5 HX profile. And we would also reference a nav file. And that nav file, right, would be kind of listing out how it's structured, what they see. So the nav file can be built to limit what they are able to see when they actually log in. So what happens is the HTML, the web interface, right, is you type in the IP address or the domain name of the supervisory device or the server that hosts the graphics, and that then you would log in using your username and password, and that would allow you to go and be able to open up the graphics based on your nav file. I mean, that's specific to Niagara, but that's essentially how everyone out there does it, is they have you use a web browser and you just open up the graphics by connecting to the IP address or domain name of the supervisory device or server that is hosting the graphics. Did that answer your question, Peter? Perfect. All right, let me get the next question in here. Okay, this was an awesome overview. Okay, thank you, thank you. Okay. So Marcos asks, I'm an operator, been a tech for over 15 years. What do I need more to learn about BAS? Well, I mean, honestly, it depends on what you want to do. So if you want to be someone who can set this stuff up, which as an operator, if you don't want to do that, that's totally fine. There's no shame in that at all. I've known plenty of great operators who all they want to be able to do is log in, see their graphics, and understand what they're looking at so they can either control or troubleshoot. My recommendation to most operators is to focus on understanding the HVAC sequencing, so understand control sequences, and understand how a building automation system uses the concepts I just went through today to control those sequences. You don't necessarily need to know how to program or how to even set these up. I would say if you really want to take it to the next level, I would focus on learning how to add field controllers, like replace field controllers, learning how to modify graphics. Those are very valuable skills for an operator to understand. So hopefully that helps, Marcos. All right. How many supervisory devices can be connected to a server? That depends on the manufacturer. I've seen as many as thousands connected to the server. I've seen servers connected to servers and set up regionally. It just depends on the manufacturer. Okay. Yeah, so Richard, I think this will really help. I think that you and I can connect offline and talk about what you asked me. Okay, so how would this rather traditional BAS system work with or without, as the case may be, a system like Riptide, a cloud-based system that touts, among other things, the ability to manage buildings around the world? Great question, Len. That's awesome. So let's talk through that. Let's use my amazing artistic talent, and that's complete sarcasm because I could barely draw a straight line, to see if we can illustrate this. So I get a lot of folks who will ask, what about cloud BAS? What you have to realize is cloud is just someone else's data center. Okay, so let's say we have Azure, Microsoft Azure, which is one of the major cloud providers. And they have your Niagara system or your Riptide system or whatever system. They have your BAS hosted in a virtual server in the cloud. Well, that is then connecting via a WAN link, wide area network, to a supervisory device in a building, maybe in Rome. Let's just pick a random city. And then over here, you have another supervisory device. And that is connected, and maybe that's in, what is something that I don't have to write a lot? Let's say ATL for Atlanta, so I don't actually have to write out all of Atlanta. And that's also a wide area network link, and that's all coming back to the cloud. Now this, my friend Len, is absolutely no different whatsoever than your customer having their BAS sitting in their local data center and them still using WAN links to connect to Rome and Atlanta. It's absolutely no different. Now, the thing with Riptide and a lot of manufacturers like them, what they are doing is they are going and allowing you to use an appliance either a hardware or software appliance, to connect to the BAS. Let's actually clear this off here. Let's erase all drawings. I like that. Erase all drawings. That's awesome. All right, so we've got our BAS, and you have, I'm just going to put a question mark because this doesn't have to be Riptide. It could be whoever. And they are an appliance that is pulling data from your BAS, which they are either connected directly to your BAS head end or they are connected to the supervisory devices. And they're pulling data for visualization and analytics. So they would go and do that. And a lot of them are trying to get into controls. They're trying to get to the point where they can actually control, either by sending control signals or by going and actually providing a user interface where you can control. That's one option. That's something that can be utilized. My thoughts on, and I will always, something with you all, if you're our students, you know this. If you're on our webinars, you'll learn this. I will always give you my honest thoughts and opinions. My only issue with some of these companies that are entering the space right now is their maturity level. And when I say maturity level, I'm talking about just from being able to serve the built and contracted environment. They have good solutions. Their solutions look steady and solid. The issue becomes when you need them to support a global environment and they don't have a local presence. That may not be an issue if you're only doing analytics, but when you start to get into command and control and you start to get into service scenarios where you need to have a local presence to help you, that's where some of these solutions, that's why I don't think they'll ever replace manufacturers' product lines, because the manufacturers' branch structures and the contractors' organizational structures, but I think they can be used to augment. They can be used to provide oversight. Where I actually see those solutions shining is contractors and system integrators utilizing them to provide analytic services to the owners, because a lot of owners don't have that tacit knowledge in-house to process the results of the analytics. So that was a long answer to your question, Len, but hopefully it helped and made sense. So off task question. Yes, this will be sent. How can we access a supervisory server remotely? Multiple different ways, either via using this software in the Fox protocol, RDP, remote desktop. Tossi Box is a solution that I was recently impressed with. It was pretty nice. So yeah. So Jay asks, can you do a class on SEQ, how to break those down? Sequences? Is that what you're asking? I think that's what you're asking. We do a class, it's called Control Sequence Fundamentals. And we literally go through every sequence. I think it's like 26 hours long. I would encourage you to pick that up. It is an amazing course. All right, so Tony asks, can I add Modbus points to a Niagara interface to monitor BAS efficiency electrical meters? Yes, you can. Right there, Modbus. You would just add the Modbus driver, you would pull it under the drivers, and then you would map it in. So there you go. Marcos says, I like to learn more and want to go to the next level. I believe you guys offer packages for classes. Yes, we do. I'd recommend that you reach out to us, or we'll actually reach out to you, Marcos. And we have a skills assessment that's completely online and free that you can utilize to go and see exactly where you're at. And that will tell you exactly where you're at skill set wise, and then we can recommend courses for you. What is the difference between BACnet IP versus BACnet LAN? BACnet LAN. Isn't that dead? BACnet LAN talk? I've never honestly seen BACnet LAN implemented in the field. I know they have BACnet LAN works. Is that what it is? But I think that's dead. I don't even think they have it anymore. The main BACnets you're going to see are going to be BACnet MSTP, BACnet Ethernet, and BACnet IP, and supposedly BACnet Web Services if they ever roll it out. LAN is a completely different architecture. So BACnet is all about structuring the messages, and the manufacturers have to implement the BACnet framework within the actual software of their controllers. LAN, actually, all of that framework comes in a chip called a Neuron ID, or Neuron chip rather, and that has everything kind of embedded in it. So it's completely different. LAN is a dying protocol. So it's pretty dead, and it's dying more every day. I do not recommend anyone standardizing on LAN. Yes, Lee and Jay, I can send that to you as well. So let me just take a little note right over here. Okay, got it. All right, let's take a look. Will I share the recorded version? Yes, I will. It will always be available on our YouTube channel, as well as you'll get an email. What system does Siemens use for their controllers? Like their legacy or their current? Their current ones, I believe, are BACnet IP. I don't. So Niagara uses, let me show you. Niagara uses the Niagara network and Fox protocol to communicate between Niagara devices. But it also has BACnet, Modbus, it has a ton of stuff, right? Andover, I think that's N2, but I thought SNMP, where can I get a Niagara license to install my computer? Well, you'd have to go to a distributor that sells Niagara Workbench, and then you would need some sort of device like I have, like a Jace 8000. Although I hear the Cipher 50 has Niagara built into it. So we're going to be getting our hands on a Cipher 50, and I hear that has Niagara actually Workbench, and because all the Cyphers have Niagara framework built into them to the edge. So and this is what I wanted to do, I just did not have time, and I could have added the Cipher 30 in here or a Cipher 50 in here, and we could have programmed it directly in Workbench using a single tool. That's kind of the whole big thing about the edge, is a single tool to program and analytics and all that jazz, which we talked about in IP controls in a webinar a couple weeks ago. So Marcos says, I have a building that uses LAN. I'm sorry, Marcos. No one should have to suffer through that. I say that kind of tongue in cheek, but it's just, I've done a lot of LAN work, and every time I have messed up a building and taken down a network, it has been on a LAN project. So one could argue that I'm just horrible with LAN. I argue that LAN is a horrible protocol. But that's just my opinion. Okay, could I share the best route that professional takes in the HVAC industry who has never done any controls design and reach a level of programming? Yeah, we actually have podcast episodes on this. So I'd recommend you go to our podcast and just look up the title career, I believe. And I mean, we have 184 plus podcast episodes. So I think it is BAM podcast. And you go here and you would type in career, and it literally a bunch of different episodes, and I would go through that. So, all right, does Niagara server have a database? Kind of, sort of. It has a Niagara database, and it can support SQL for export capabilities. So Niagara Workbench, are all the Niagara Workbench from different brands compatible with each other? No. Well, as far as my understanding, no. I've always used Vikon, and my experience working on other systems like Webs um, and FX is where you had to utilize Webs and FX versions of Workbench. What is Honeywell EBI? It's their flagship product last I checked that they utilize for enterprise building integration, if I remember correctly. So if we bring it up. Pew. Enterprise Buildings Integrator. There we go. Here you go. Right here. The EBI suite. Take you through all of it. That's great, Jay, that you've listened to so many podcast episodes. I appreciate that. So Marcos asks, reach out to me. Okay, I will. And Howard says, what is Honeywell EBI 410? I don't know. I'd have to look it up. Well, I mean, there's the manual. I mean, this is what I would do. Basically, I would just read about this. So essentially, it is a unified single pane of all glass or single pane of glass that integrates a bunch of different systems. And it looks to be pretty legacy based on the fact that it's 2008 and Windows 7. There's a sample architecture. So this is kind of what I do whenever I have to go and look stuff up. So Jay says, I'm finding looking for you under YouTube is kind of hard. Well, that's because you're looking for the wrong YouTube? I don't know. It's posted on the Facebook group all the time, Jay. So I have no idea. But they should be there on the Facebook group. And then Brandon says, got to run. Thanks for the webinar. You are welcome. And now the rest of you remain. Any questions? I will stay here as long as you all have questions. I've got a pack of peanut butter crackers and I've got some coffee and the world is great. So Robert says you just need to search Building Automation Monthly on YouTube. Look at you, Robert. There we go. But for the rest of you, what other questions remain? So Nicholas says he is new to building automation controls and looking forward to becoming an expert. That's freaking awesome, Nicholas. I'm glad to hear that. Feel free to check out our podcasts and our guides and our free videos and our YouTube channel. I think it will help a ton. And Tony says, thanks for the webinar. You're welcome, Tony. All right, Marcos, I will reach out to you. Oh, Nicholas said his company has enrolled him in our Niagara Basics course. That's awesome, Nicholas. Thank you so much. And Lee, yes, it's great to see you as well, Lee. And Jay, it's good to see you. It's good to see the regulars in here. What all would you recommend taking for training when starting out? So it depends on your goals, but our technician path has resulted in more people being able to step into technical and programming building automation work than I think any training out there. We've had a really good success rate with that, taking folks who knew nothing and teaching them how to program and install controls in about 3 to 6 months. So I would recommend that technician path That works really well, and a lot of companies are using that. So I can send you some info on that, Nicholas. Howard, you know what, Howard? I really appreciate that. Thank you. He says I'm doing a great service to the industry and looks forward to learning from us. I really appreciate it. I wish more folks would actually do this instead of just, hawking products at people for an hour. I wish folks would just like get on here and share knowledge. Distech's doing a really good webinar series with oh my gosh, why do I always forget their name? They've got to get a better name because I can never remember their name. Optigo Networks. So Optigo and Distech do a really good webinar series. So I'd recommend checking them out there. They're one of the few that do really good stuff out there. Do I recommend BACnet IP over BACnet MSTP? So I'll give you the short answer, and then I'm going to refer you to our previous BACnet IP webinar that we did. Well, not BACnet IP. We did IP controls webinar, and I would refer you to that because that answers the question in greater detail. BACnet IP is good when you want to have high-speed communication, you want to connect to like a central plant or air handler controller, and you want to have graphics and everything standalone in that controller in the case of network or supervisory device failure. BACnet MSTP is good for field controllers like VAV boxes and terminal units, where you're more acceptable if those controllers go down and speed and capabilities is not as important to you. All right, so I see Mishak wants to know more about the technician training path. Got it. I will send that to you. Yes, there is, Nicholas. There is a package for the technician training path, and I will send you that info. All right, what other questions you guys got? This can be specifying questions. This can be questions related to, owner questions, operator questions, retrofit questions, basic BAS 101, anything you guys want to ask. And gals, in today's culture, you got to say guys and gals. You don't want to offend anyone. Oh, man. I shouldn't have opened that can of worms. But sometimes I just say what's on my mind. For either of the training paths, do you need access to a BAS system or build a lab, or is it possible to learn it through a simulator? Great question. So for our technician path, the install course, you definitely need product. We have a blog post that I encourage any of you all who are trying to work on building automation systems, find a way to do this right here, which is building a BAS lab. I'll send this out in the chat. I will send it to everyone. There we go. This is a good blog post on building a lab. As I mentioned, I recently learned that the Cipher 50 actually enables you to do the same thing as a Jace, supposedly. So that's an all-in-one. It's BACnet IP field controller with I/O. So I would recommend looking at that. Now, our programming course, you can completely learn to program without physical product. So we can teach you to program. The only thing is installing. I mean, you've got to have controllers and I/O to install. Otherwise, you won't get the same experience because you won't be hands-on. But I mean, you could put that together for not too terribly much. I'll follow up with you though, Dimitri, about that. All right. Um, Saeed, is that how I say your name, Saeed? I love your questions. You've been here in the previous webinar as well, and you always ask good questions. Can always count on you to have one. That's awesome. So what communication infrastructure is recommended for retrofit? That's a great question. So a lot of folks, they're doing retrofit projects. And I think really, so for those of you who are still here, I'm going to give you a golden nugget. The industry, those of you who are prepared for the retrofit market are going to be making buku bucks in the next 5 to 7 years. Because what's happening, and I'm actually speaking in Tampa Bay at Train about this topic next Tuesday, is that you've got all these legacy building operators who are in their 50s, and they've been maintaining these legacy building systems. And what's going on is these legacy building systems, you can't buy them anymore. And so they've been maintaining them, but they're going to retire. These folks are retiring. And what's going to happen is all that tacit knowledge to maintain those legacy systems is going to go bye-bye. And you're going to find all these people like, oh crap, we can't operate our buildings, we can't operate our hospitals, our universities, etc. Can't control the HVAC because things are dying. We can't buy them off eBay anymore. And they're going to look for people to do retrofit work. And the folks who are prepared, who have been talking to their owners and planning out a life cycle plan and have got that all lined up, are going to just be able to rake in the retrofit dollars when that occurs. And you're already starting to see it occur, but we're kind of like following that standard deviation curve. Like if you look at my screen, right? If you ever follow statistics, you have kind of a curve that goes like this. And we're right here, kind of right here right now, but we're going to be hitting right here pretty soon where the percentage of buildings needing retrofits is just going to hit that high mark. And the folks who are preparing for it right here, preparing their businesses and talking to their customers about it, are going to be grabbing most of this market share. And that's why you see a lot of companies making acquisition decisions based on this, as well as analytics capabilities. So that's going to be pretty cool. All right. So, and speaking of that, Lee, am I all wet on that? You operate a building. You operate several buildings. So is Lee still in here? I think he was. Maybe. Not Lee Turner, but the other Lee. Okay. Maybe not. All right. So anywho, so back to the communication question, infrastructure. Yes, I know all the Lees on here. So to the question of infrastructure retrofits, the only thing with wireless is great if you take into account EMF, electrical interference, basically, and you can actually lay out a wireless system. A lot of folks think they can just go install wireless and it all works beautiful because it's mesh and it's going to be amazing. The reality is you still need to understand wireless signal strength, and you need to place the systems so that they overlap and the antennas have line of sight. And if you understand that and you have the expertise to do that, wireless can be pretty awesome. If you don't have the expertise, then it can just totally hose you and make you stuck on a job. Where do I suggest you start with our programs in becoming efficient in BAS from navigating to programming? Well, I would recommend our skill assessment. It's the thing I always recommend to folks. And then based on that, be able to really understand where you're at and make recommendations on courses. So. Do I have any guides to following to creating a graphics standard? Actually, I think we do. I don't know if it's in our book or if it's on our website. Graphics. I mean, that's on how to evaluate graphics. If you haven't read this, How to Evaluate a BAS, this is a great blog post. It talks about building spec language, all about how to evaluate that. I really think it's in our book. I will check that and get back to you, Lee. So let me do that. Okay. And put book graphics. Okay, perfect. And that and follow up. Okay, let's take a look. Will your training ever be offered in a format that is able to be paid for by FAFSA or other? Good question, Michael. Amazing question. Something that has been on my mind so much, because I know that we are missing so much of the market by not offering FAFSA, that kind of stuff, or GI Bill. It's something I have to figure out. As far as time frame on figuring that out, I'd be lying to you if I told you when. We have a lot of things in the hopper right now as far as companies we're working with that want us to create training for their products. You'll see some of that probably announced at the beginning of the calendar year, and they're big companies. So you'll see that, but that is definitely an area. What I've been debating is two things: either doing something like what Code Academy does, where we have an employment agreement where you basically don't pay for the training, and then when you get a job above a certain salary, you start paying back the training. That's one method. That's what Code Academy does. You basically go through their Code Academy, you learn to program. This is computer programming. And then as soon as you get a job making above 40,000 a year, then you start to pay back the training. That's one way I've been looking at it. The other way, obviously, is student loans and that, but I'm not sure what that takes. Any other questions? This is all good stuff. I love doing these. If you haven't, by the way, when you leave, fill out the survey. That way I know what you all want to do for future webinars. I know some folks have asked for a BACnet one. Some folks have asked for another programming one. I've had one where someone was like, "Hey, teach us Metasys." I'm like, "No, I'm not gonna. We're not gonna do product-specific ones." But I tend to stick with the general topics on these. So, any other questions? Yeah, Michael, that is actually something I've been looking into. I'm going to be talking with a guy at Ferris State next week, who's their program director. I'm also looking at the MTAC, which is the Milwaukee Technical College. So I'm looking at talking to both of those. That's actually, Michael, you have just made my day. I did not even think, I mean, I thought about working with a college, but I didn't think about working with it and then funding through them. That's actually a really smart idea. See, you all are helping me. That's why I love these things. What else can I answer for y'all? Generally speaking, how about global transfers like subroutines, how they work and setting them up? Do you work with Allerton, Jay? Like, is that your product that you work with primarily? I don't normally hear folks say subroutine unless they work with visual logic. So something you can actually do in Niagara, if we go to kit control, files, labs. Why is there a bright red square? I don't know what I was doing with that. Okay, so if we go here and I go to kit control and I go to logic and I go to expression logic and we open this up, you can actually do some logic in here. So you could run a for loop essentially in this expression logic because it's a be equal expression. So you could run a for loop if you wanted to. Just so you could, grab the average damper position of every VAV box or whatever, for a trim and response sequence, something like that. What systems commonly integrate or interface with Niagara Workbench through BACnet? That's a tough one. I mean, everyone. I mean, if it's BACnet, then they probably have been used. I mean, BACnet, the whole purpose of BACnet is to be open. So I see Mirza, I think I said that right. You can use subroutine DDC to make your DDC more efficient. You should program a subroutine anytime a calculation or control sequence needs to be implemented repeatedly. For instance, you need to convert FPM to CFM or for a number of VAV boxes. Yeah, exactly. What you should not do is do this, where you go and, let me show you. Where is it? Where's my trim and response? I don't know where it went. It's disappeared. It's gone forever. I don't know. It disappeared. I was going to show you an example of not using a subroutine, but rather just using a bunch of averaging blocks, which is a way you should not program because it's super confusing. All right, folks, what other questions can I answer for you? All right. Well, I'll give you guys a couple more minutes to ask whatever you want. I'm going to lower my adjustable standing desk. This is the most awesome thing ever. But yeah, just take your time. Any questions you want. And then if I don't see anything by 12:25, then we'll call the webinar and you all will have a rest of your awesome day. You're welcome, Lee. Can I talk about point name descriptors like camel case or just using white space? Yeah, so if you try to just use white space in Niagara, because it's programmatic, you will get some goofy results. you will get these kind of wildcard keys and all that jazz. So what I often like to do is go and I will add an object, right? We'll call this, I don't know, just ZNT, right? Zone temp. And then what I like to do is set display name. Now this only works in Niagara. It's not universal. And this is why I recommend a naming standard. But if I do that, right, and I say zone temp, now what's going to happen is this is displaying a zone temp. But if I click on the object, you see it's just ZNT because I set a display name, because that display name is metadata for this object. That way I can still refer back to the URL of the object. As far as naming standards go, so camel case, right? You know, ZNT, or it would be like, actually be like this. So there's camel case, there's inverse camel case, there's, you know, just straight up all caps, there's underscore. I mean, it all depends on what your manufacturer software supports. Ultimately, it depends on the customer's naming standard. Excuse me. What other questions can I answer? All righty. Well, seeing no more questions, I will go and make myself a peanut butter and jelly sandwich and have lunch and go from there. I see Howard says he just signed up for the student assessment. That's awesome. Thank you so much. And there we go. I'm an old school HVAC mechanic at university with no funding for training. I'm trying to glean information from the internet to teach myself what I can about controls. Your website has been great. Most is way over my head. Well, you know, hey, I totally respect that. I think it is very honorable for folks who try to go and develop themselves. That's really cool. What I would recommend doing is going and seeing if your library carries our Building Automation Systems A to Z book. Now, it won't be the same as going and buying it off our site where you get the videos and all of that. But if you can pick up a copy of this, it is not a technical book. I want to be clear on that. I get some comments on Amazon and they're like, this book isn't technical, it's horrible. It's written like he's having a conversation with you. I'm like, well, yeah, no crap. I mean, that's the point of the book. So, yeah. So I would recommend getting that. That will help you a ton, John. I'm working on writing DDC for chiller plants. It has heat recovery chiller from multi-stack in a side stream. With chillers, can you talk about chilled water set point reset control in case there's not much written in the sequence? You know what? Wait a couple podcast episodes because right now we are in a series on HVAC control. And we just covered rooftop units, fan coil units. This coming week is air handlers. The week after next if we get through air handlers, will be boilers and then chillers. So about 3.5 weeks from now, we will be diving deep into chillers. In the meantime, like I said, our control sequence fundamentals course is really solid. Basically, when you're looking at chilled water set point reset control and you've got a heat recovery chiller, there's a lot to that. In the meantime, I would do this. I don't know if they have heat recovery built into it, but this is one of my favorite places. Is Control Spec Builder. It will actually enable you. You just got to trust me on this because I'm not going to enter all this information. You know what? I will. Okay, test 1. Okay, let's just go next. Okay. And then you can go here, chiller, and you can start to select chillers. Do they have? I don't see a heat pump or heat recovery chiller, but this is really good one to build specs out of, by the way. Mishak, I'll have my admin reach out to you. So, but yeah, so heat recovery chillers, they'll just I'm going to teach you all a trick. Sequence of operations file type PDF. If you type in whatever you're looking for in Chrome or in Google search and then type file type PDF, what will happen is you will get all of the results in PDF format. And we can see right here, waterside heat recovery train. And this, I love train newsletters. These are freaking awesome. So this one tells you almost exactly what you're asking about, and it's going to go through. This would be a really good read for you. You did? Okay. Well then, I would just continue to read through these because this conversation honestly would be probably another hour to go through all of that. But I will make sure we talk about it in the podcast. So Mishak, I said my admin will reach out to you about book. Got it. What is a heat pump? It's essentially a device. Are you talking heat pump chiller or heat pump like fan coil unit? Because vertical stack heat pump essentially is a device with a compressor built in with a reversing valve that can reverse the flow of refrigerant to not just remove heat from the building, but also add heat to the airstream. Excuse me. And that's something we talk about in our control sequence course. All right. Okay. Not seeing any more questions. So oh, yes. When will the recorded session be available? I don't know. Probably Friday. Probably Friday. I have our production team working on so much other stuff that I think that's when they'll get it because they've got a couple videos and a bunch of other stuff that they got to produce. Have I ever considered putting together a consultative sales seminar? What would that look like? We should talk about that offline. I'll reach out to you. So I will reach out to you to find out what that looks like and what you're thinking. Because something we're starting to do is we're starting to offer online sessions like this to owners to teach them and their team about building automation. Granted, those are things we're charging for, but we're starting to do that for some owners who want to train their organization. And it's like a 2-hour session dedicated to them, and we go through whatever they want to go through. All right. So this will be the final call for questions. Our Niagara course does not offer a certificate of completion. It is not meant to be a replacement for N4 certification training. It is meant to assist folks who understand Niagara by providing a resource that they can refer back to. It's meant to be a like a repository of steps in video format that people can utilize. You're welcome. All right, so with that question, I will call it. Thank you so much for everyone being here. This is awesome. I appreciate you all. Don't forget to fill out the post-webinar survey. That really helps us to better things. And I appreciate having all of you in here. Appreciate your time. Thanks so much. You all take care.